Hello, welcome to Astronautics for Experts. This is Dr. Ayanshola Ogundele. Applications of solar cells in space exploration, a revolutionary approach for propelling spacecraft through deep space. The focus points are as follows: solar celling, an application of solar cells in space exploration. The use of solar cells in space exploration marks a paradigm shift from the conventional fuel-based spacecraft propulsion systems. To propel spacecraft, solar cells make use of radiation pressure principle. Generally, solar cells have large reflective cells that capture the momentum of light from the sun and use the momentum to push the spacecraft forward. Potential applications of solar cells are interplanetary travel, spacecraft propulsion, asteroid and comet exploration, solar monitoring, long-endurance satellites, earth polar exploration, space debris removal, formation flight, flybys and rendezvous, and interstellar exploration. In the area of asteroid and comet exploration, solar cells have the potential to be used for the provision of a continuous fuel-less propulsion system. This will enable spacecraft to reach distant celestial bodies with less mass, making extended missions and close flybys of small asteroids and comets possible. For long-endurance satellites, solar cells are ideal because they utilize the continuous pressure of sunlight to propel a spacecraft. This aids extended missions without the need for large amounts of fuel, making them perfect for long-duration space exploration, where traditional propulsion methods might fall short. Solar sailing. Sailing through space is the ideal of using solar cells to propel spacecraft. Solar cells are large reflective sheets that use the sun's light to push a spacecraft forward. Although sailing through space using solar cells has challenges, such as the need to be large relative to the spacecraft to generate enough thrust, the sail accelerates slowly and the design is challenging. It has a lot of advantages, such as no need for propellant. Icarus, the first space probe with a solar cell in flight, is shown in this picture. Applications of solar cells in space exploration are interplanetary travel, spacecraft propulsion, asteroid and comet exploration, solar monitoring, long-endurance satellites, earth polar exploration, space debris removal, formation flight, flybys and rendezvous, and interstellar exploration. Interplanetary travel. A solar cell-propelled spacecraft could reach distant planets and star systems much more quickly than a rocket-propelled spacecraft because of the continual acceleration that solar sailing provides. The technology for interplanetary or interstellar solar sailing is at infancy. For trips within the inner solar system, solar sails can deliver payloads and then return to Earth for subsequent voyages. Operating as an interplanetary shuttle, for Mars in particular, the craft could provide economical means of routinely supplying operations on the planet. Artist's concept of nanosail in space is shown in this picture. Spacecraft propulsion. Solar sails use sunlight to propel spacecraft through space. They are a non-consumable propulsion system that can travel indefinitely because sunlight is free and unlimited, unlike rocket fuel. Solar cells can propel spacecraft without using chemical or electric propulsion. This allows for constant acceleration, which can reduce the cost and risk of space travel. Solar cells provide a constant slide thrust, which can help spacecraft reach higher speeds over time. Like a true illustration with the deployed solar cell is shown in this picture. Asteroid and comet exploration. Solar cells could play a crucial role in the exploration of asteroids and comets. Since these objects may be located at great distances from the Sun, ability to conduct long-term missions without relying on chemical space propulsion would be a significant advancement. Solar cells generate a very small but continuous thrust, ideal for long-term acceleration needed to reach distant asteroids and comets. Near-Earth asteroid scout. is illustrated in this picture. Example of solar sail missions for asteroid and comet exploration is NASA's Near Scout. Researchers are exploring the possibility of using solar sails to reach distant comets in the outer solar system, allowing for detailed analysis of their composition and behavior. Illustration of advanced composite solar sail system is shown in this picture. Solar monitoring is another area of application. In the near term, solar sailing can be used effectively for other classes of missions including solar monitoring, multi-object flyby and pole-sitting spacecraft for continuous observations of Earth or another object's polar region. Solar sails can be used to monitor the sun for solar storms. NASA's solar sail system is illustrated in this picture. Long-endurance satellite is another application. Satellites equipped with solar sail systems could be kept in operation for much longer periods than current satellites. Solar sails are ideal for long-endurance satellites because they utilize the continuous pressure of sunlight to propel a spacecraft. Concept image of Okeanos mission is shown in this picture. Earth polar exploration. Solar sails could be used to explore Earth's polar region by placing spacecraft in orbit over the poles. Solar sails use sunlight to propel spacecraft, which could allow for continuous observations of the poles. Potential uses of solar sails for Earth polar exploration are polar-sitting spacecraft, space weather monitoring, and communication relay. Illustration of sun-jammer solar sail is shown in this picture. Space debris removal. Solar sails use solar radiation pressure to remove space debris by generating thrust. They can be used to deorbit satellites or to raise their orbit. The working principle for space debris removal is as follows. Deployment. A spacecraft can deploy a solar sail using a tether or a grip. Thrust. The sail's large surface area generates thrust from solar radiation pressure. Drag. The sail's increased cross-sectional area creates drag, which slows the satellite's orbit. And re-entry. The drag slows the satellite enough that it burns up in the atmosphere. Illustration of solar cruiser is shown in this picture. Formation flight. Solar sails for formation flight refers to a concept where multiple spacecraft equipped with solar sails fly in a coordinated pattern, maintaining specific relative positions to each other. Solar sails in formation flights could be used for advanced space missions that require multiple viewpoints of precise positioning, like high-resolution imaging or studying complex celestial phenomena. An artist's concept of a breakthrough starship spacecraft is shown in this picture. Flybys and rendezvous. A solar sail can be used for flybys and rendezvous with celestial bodies by leveraging the continuous, albeit small, thrust provided by sunlight pressure, allowing for a spacecraft to maneuver and reach distant objects. Solar sails are suitable for missions to asteroids, comets, and interstellar objects. Illustration of Cosmos 1 spacecraft is shown in this picture. Solar sails can be particularly beneficial for exploring small celestial bodies like asteroids or comets, where the gravitational pull is weak. A potential strategy for rendezvous involves utilizing a static configuration where the sail is positioned to counteract the sun's gravity. Artist's concept showing the advanced composite solar sail system is shown in this picture. Interstellar exploration. Solar sails could be used for interstellar exploration because they can propel spacecraft without fuel. Solar sails could be a low-cost way to explore the outer solar system and interstellar space. Namias 2, after the deployment from the Progress M15 spaceship on February 4, 1983, is shown in this picture. For more information, contact Astronautics for Experts. You've been watching and listening to Applications of Solar Sails in Space Exploration, a revolutionary approach for propelling spacecraft through deep space, presented by Dr. Aynshola Ogundele, with the focus point, solar sailing and the application of solar sailing. Thank you.